Hello, welcome back. Now we are on the project of design of CMOS Digital Integrated Circuits 1. This is as access control and room alarm. So first of all, I'm going to explain the main idea of this project. The objective of this project is to design and implement an access control system with integrated room alarm functionalities. The system will utilize a pyroelectric sensor for motion detection, a 4x4 keypad matrix for password input, and an alarm buzzer for unauthorized access alerts. And finally, we are using an illumination light bulb for um, illuminating the area or the room, and we are implementing a Max10 FPGA system for the control and integration. Now, the key features. We are using an access control via keypad. We are using a motion detection via a pyroelectric sensor. And we are using an alarm activation logic. And this logic is the following one. If no password is entered, the system will assume that it's an unauthorized access and will activate the alarm upon motion detection. Now, what happens when you introduce an incorrect password? Well, similar to no password entry, incorrect password will keep the alarm system activated. Now, what happens when you enter the correct password? Well, this will deactivate the alarm but keep the light bulb operational. So, first of all, we have the library declaration. So, which provides a standard logic definitions. The access control entity is defined with its ports, including input ports for the clock signal, that is called reloj, and column signals for the keypad, call, and motion sensor, and output ports are defined for the keypad rows, filas. The 7-segment display, segmentos, and the light, foco. And finally, the alarm buzzer, that is called buzzer. This is an output, by the way. Now, the architecture. This is teclado matricial of access control. So, the constants of these signals are the following one. It's defined as a 16 vector representing the correct password in hexadecimal. Several signals are also declared to handle button press, that is called button press. The integer signal is named int, and the 7-segment display output seg. The enter password, a flag for password correctness, password correct, and a counter for button press count. Finally, we have the flag for alarm activation, alarm activated. So now let's jump for the second part, that is the keypad handling processes. So the process of teclado process handles the keypad input for the update 7-segment display accordingly. It operates on the rising edge of the clock signal. So when button is pressed, indicating 1, the process checks which button was pressed and updates the segment signal to display the corresponding character on 7-segment display. It also updates the enter password signal with the process button value and increments the button press count. Once 4 buttons are pressed, the enter password is compared to the correct password. Updating the password correct signal, the button press count is the reset for the next password entry. So as you can see in this part. Now the process control of the clock signal. So the process control manages the motion sensor input and controls the light of the bulb and the buzzer. It also operates on the rising edge of the clock signal. When motion is detected or the sensor is equal to 1, the light is turned off. The bulb is turned off or 0. If the password is incorrect or not entered, password correct is 0, the buzzer is activated. Buzzer is equal to 1. If the password is correct, the buzzer is deactivated. The buzzer is equal to 0. When no motion is detected, the sensor is equal to 0, the light is turned on, the bulb is equal to 1, and the buzzer is deactivated. Finally, we have the output assignment. The segment output is assigned to the value of the segment signal, which drives the 7-segment display, and the teclado matricial.
Hi everyone, welcome to practice report number 20. This is our final project. It's a system alarm with room detect. We have a matrix 4x4 that we are gonna use to introduce our password. We are using a buffer 245, a relay module connected to the light bulb, and of course our FPGA Max 10. So here's how it works. If you manage to put the right password and you open the door, the detector, the sensor is going to detect your hand and it's gonna send a signal to the FPGA. But the buzzer is not gonna emit any sound. But if you make one mistake with the password, I don't know, if you put the wrong password and you open the door, the sensor is gonna detect you and the buzzer is gonna start making sounds. The other case is that the user doesn't introduce any kind of password and just open the door. The sensor is gonna detect the hand of the user and the buzzer is gonna start making sounds. So in order for the user to reduce or stop the buzzer to make sounds is to introduce the right password. So I'm gonna make an example here. If I open the door, the sensor is detecting my hand, as you can see there. Well, so the way we need to stop the buzzer to making sounds is to introduce the right password. Is FFFF 1, 2, 3, and 4. And as you can see, the sensor is not gonna detect my hand right now because I introduced the right password. And that's everything. Thank you so much for watching this video. Everyone, welcome to practice report number 20. This is a project. This is access control and room alarm. We have a password to enter to the house. If somehow you manage to put the right password, you will open the door and there will be no alarm. The buzzer will not sound. But if you put wrong password and you open the door, the buzzer is going to beep and the light's gonna be turned on. Okay, so I'm gonna give a demonstration here. I'm gonna open the door and the sensor detect me and the buzzer beep. But if I put the password, that is FFFF 1, 2, 3, 4, and I put the hand right here, as you can see, the sensor is not longer sending the alarm to the buzzer, and it's detecting me. As you can see, the light bulb is turning on. That's why that's because I put the right password. And there you go. Thank you so much for watching this.